Hi everybody. So in today's video, I'm going to be programming the Jump Diffusion stochastic differential equation in order to model stock prices over a period of time. So I have my market data function over here, so let's see what happens if I do ticker equals, I'll do NVIDIA, and then I will do data equals market data of a ticker, and then print data. So I come over here, do Python 3 jump.py. Okay, so Panda's data frame of stock prices has loaded. What I'm gonna do now is extract the close. So I'm gonna do close equals data of adjusted close dot values. So now looking at these inputs, let's start extracting some of these. So first I'm gonna take out S of t. So S of t is gonna be the latest stock price, so close minus 1. Mu is the drift and sigma is the volatility. So I'm gonna do mu equals. Oh wait, first I have to do ROR equals close 1 divided by close -1 minus 1.0. So then I'm gonna do mu equals the mean of the rate of returns, and then the volatility is gonna be the standard deviation of the returns. So let me go ahead and print these out. So S of t, mu, and volatility. So I'm going to come over here, reset. All right, let me get out of this. Okay, so then I'm going to do Python 3 jump.py. Okay, so this is the stock price of NVIDIA, this is the drift, and this is the volatility. So now that I have these three, I need to declare some more variables. So I'm going to be forecasting this. So I'm going to put t equals, I'm going to forecast this stock price to like 7 days. So I'll do 7.0 divided by 365.0. And then n is the number of steps I'm simulating. This will equal 200. So dt is going to equal t divided by n. Okay, so now that I have that, I'm going to code the jump diffusion model. So I'm going to come up here and do define jump diffusion. So it's going to take the argument of stock price, drift, volatility, delta time, jump factor, and n. So I'll create a list called prices, and then I'll do for I in range n. So this is going to be stock price plus equals stock price times, let me just do it as the formula says right here. So first it's mu times stock price times dt. So it's going to be mu times stock price times dt plus volatility times stock price times. Okay, so this is where we need to get the dwt and the dnt from. So I'm going to come here and do dwt equals numpy.random.rand n of n, and it's going to be multiplied by the square root of delta time. And then now I need dnt, so dnt equals numpy.random.Poisson of, I will do this as mu times delta time, size equals n. So now I can just fill in dwt of I plus the stock price times e to the power of the jump minus 1 times dnt of I. And then this is going to be prices dot append stock price. So I will come up here and initialize it with the initial stock price S of t. So this is going to update that and then return prices. So now let me just go ahead and print jump diffusion of S of t, mu, volatility, delta time. I'll set jump equal to 0.3 and then n. So come here. Okay, there's a, oh, it's v of I, not v of t. Sorry, my Virginia Tech fans. Okay, so reset that, run it. Okay, so I have a simulated list. It's barely going up. Let me do uh 0.5 times delta time. So reset that. Hmm. Yeah, these are pretty like frozen. Okay, let me go ahead and increase this to 5.5. So reset. They're still coming out like a um yeah, there's not much like volatility in them. Oh yeah, the spider tattoo. Let's see. Maybe if I take away the square root. So reset. Okay, now there's some variability. Okay. Um, so then maybe I'll just, let's see what happens if I put it back to 0.5. Okay, good. Yeah, so this is simulating, so now we can move on. So what I'm going to do is create a variable called jump, and it's going to be the numpy.arange of 0 to 1.01. 0.01 is the increment. And then time, I'll call time equal to list range of n, and then it's going to be x and y equals numpy.mesh grid of jump and time x. So then for j in jump, I'll do z equals empty list here, and then I'll do z.append this jump diffusion function. So control X, control V. But instead of this 0.3, I'm going to replace it as J, so that way I could incorporate the jump parameter. And that closes, so it's going to be z equals numpy.array of z. And then I'll do figure equals plt. Well, actually, let me print out the dimensions of these. So print x.shape, z.shape, y.shape. Okay, so didn't mean to do that. Let me reset this, run it. Okay, oh, right, right. It's supposed to be n plus 1 because I add the stock price at the beginning of it. So now let me run this again. 201, 101, 101, 201, 201, 101. Okay, so instead of that, actually, yeah, time is supposed to be the x variable and jump is supposed to be the y variable. So let's go ahead and, so I have Matplotlib in here. So I'll do fig equals plt.figure. Fig size equals 7 by 7. And then ax equals fig.add subplot 111 projection equals 3D. And then it'll be ax.plot surface of X, Y, Z. Color map is going to be Viridis, and edge color is going to be black, and line width is going to be 0.5. And then I'm going to do ax.set x label equal to time, ax.set y label equal to jump, and ax.set z label of stock price, and then ax.set title jump diffusion stock price simulation, and then plt.show. So now I'm going to come here, run it. Okay, and we have the jump diffusion over here. So we can see that the time variable is x, the jump parameter is y, and the z parameter is the stock price. So this is the jump diffusion stock price simulation. I'm going to keep this here. I want to look, actually I might as well add the ticker as well. So I'll do plus ticker, and I'll write 4. So now I'm going to run it with a different stock. This time I'm going to do Apple. So run. Okay, so we have these. So this is for Microsoft. This is for Apple. They certainly don't look the same. But yeah, we can see their simulation here. Let me go ahead and do it for let me get rid of that terminal. So I'm gonna increase the parameter to 30 days. I'm gonna make n equal to 300. Um, yeah, I think that's good. Maybe if I do fig.tight layout to make the plot bigger. So now I will do it for what's a good stock that's always in the news. Microsoft. So yeah, let's see what Microsoft's Jump Diffusion looks like. So run it. Okay, so sorry, I had a cough. Um, yep. So this is the Jump Diffusion surface for Microsoft, and as we can see here, it's like a good Monte Carlo simulation. Actually, let me take out the fig.tight layout. Um, I'm gonna simulate this for 1 day now, and this time, so I did Apple, Microsoft, Nvidia. Let's do Amazon. So yeah, this will be the last simulation of the video, so I will run it. And we have it. So we have the Jump Diffusion stock price simulator for Amazon. If we put it like this, we could see like the full paths, but we make the 3D component to the jump. So yeah, that's pretty much it for this video. I thank you all for watching. I'm gonna keep coming out with more and more good content, so stay tuned. Peace out.